First of all, what I want to ask you to do is just close your eyes for a minute and just look at the back of your eyelids, and you'll realize that what you see are like basic use cases like virtual CPE and security and cloud. So if you do that, what I want to do today is kind of change the topic a little bit and show you some different use cases that we're exploring at Fujitsu, along with those other traditional ones that everyone talks about in these conferences. So hopefully that makes sense. First of all, at Fujitsu, what we do is we're working with different companies and our customers on different problems that they face from a workflow and orchestration and automation perspective. One of the problems that you're probably aware of, but you've been thinking more about security and virtual CPE, is the problem that's associated with how optical networks are deployed today. I think this is something Nancy mentioned earlier. There's these silos that are deployed today for various reasons, right? Because the operator had different network performance parameters, or the operator had different capital or operational needs, or in most cases, operators are consolidating, so their networks are consolidating, and they consolidate different vendors' products and different networks. And the nature of how optical networks have been deployed means that they're basically siloed on a vendor perspective. And there's a lot of history there I'm not going to get into today, but just rest assured that if you talk to any operator that's attending this conference, if they have an optical network, it probably has multiple domains or silos in it. Now, this is very complicated, right? Because to manage these networks and to stitch services across these optical networks, they have to really do a manual process, right? And we're in the age of automation and trying to orchestrate things, and that's the challenge that we face our operators face, and we face with them, right? It makes it hard for them to do planning. They have different organizations that do that. They have different teams that understand different vendors' products in most cases. And it's just not possible also for them to extend their service beyond, to their end customers and have their end customers do zero-touch provisioning of their own network. So basically, this leads to higher operating expenses and makes it very rigid and manual to manage these services. So hopefully that makes sense, and if you're probably nodding, yeah, I see that. One of the solutions that we propose is what we call having a federated controller of optical domains, right? And what allows us to do this today is having a framework in place that would support the ability to support these workflows, and having the ability now to have these open interfaces that we can interface with these individual controllers. So from a Fujitsu standpoint, the way we approach this was we have this optical service orchestration function, right? Not yet another product to add, but a function that's added, and that allows you to open interfaces to the different vendors, vendor A, vendor C, Fujitsu domains, even the new open ROADM standards in the optical domain. And it allows you to stitch and control these, basically treat these domains like abstracted network elements, right? And by doing that, you abstract the endpoints of those network elements and treat them like a cross-connect between those endpoints. And then it allows us to stitch services across these without knowing all the details of what's going on. It's almost like you with your computer, right? You don't know all the bits and bytes that are going on inside your computer, but you have software that abstracts all that and allows you to do your work. And that's what we did, what we did here, right? It gives you, again, ability to provide tenant zero-touch provisioning, ability to orchestrate, and as you'll see in a minute, orchestrate lifecycle services and manage those across, the different domains. Here's just an example of like day one as an instance. And as you can see in this image, you have 3 domains, A, B, and C, and those have different domain controllers. And in order to deliver a service, what the orchestration function does is it uses this abstracted information that's harvested from the network and allows the service provider to create a service, let's say from point 1 to point 6, by calling the different controllers and allowing them to giving them information about what you want that path to take, right? What are the attributes of that path? Is it low latency? Is it the ability to, reduce the sRRG or the protection of the network in a sense? And then each controller does what it does best, right? It provisions services for that optical vendor's network the best, and it comes back and says, yeah, that service is ready for you to deploy. So that's kind of a day one scenario. There's also the day two and on management and the lifecycle management from an optical service perspective. So the orchestrator will keep track, given events and so forth, about what are the faults in the network, what events happen from each one of the controllers, and also has the ability to do troubleshooting and network management perspective. Now this is a real problem that's faced today, and providing the solution gives the vendors a capability of not having to rip and replace all this stuff, which is really, there's a lot of investment in there. So having the ability to utilize what's currently there is important. And again, the key to this is to use an open interface. And we've been working with the Transport API organization to introduce functionality and capability to support the interfaces that are required. Hopefully that makes sense. What I wanted to add here in this chart is just an extension of once you're able to do this from a, create a service capability for a customer and allow that service provider to stitch this together, it gives them the capability now to virtualize their network. In the sense, the way we virtualize, hardware or CPE or compute hardware or storage, and allow tenants to now manage their network themselves, or give a piece of that optical connectivity network to that tenant. And now you can virtualize and give them a portal. The other thing that you can do that's really interesting is you can connect this, because it's open interfaces, even northbound, to a CRM and have Salesforce or some other CRM system actually manage that customer service model, and it makes it a lot easier to deploy. Again, if you're an operator and you're doing things manually, this is like a leap into the future, really. So this is fantastic. Again, really the important thing here is you have the ability for that tenant that you give that service to do zero-touch provisioning, right? They don't have to call you up. And as they add that service from an operator standpoint, you're generating revenue on this infrastructure that you have deployed, right? So that's definitely positive. So what really is the enabling? I'll talk a little bit about the enabling framework that we use and the architecture that we use, just to give you a sense of the capability. So one of the things that's important here is, if you start from the bottom out, the infrastructure that's in place is one, that you have a build and run time environment. That way, as you build new capabilities, and I think a lot of the infrastructure that's in place, or the software that provides this capabilities, there has build and runtime environments, but you can add new capabilities as you go along. The important thing, if you look at this, is you have to have an adapter library that can configure and adapt to the different controllers that you're controlling, right? All the optical vendors have some legacy systems that may even talk, dare I say, Corba or some other interface, and you have to have an adapter to adapt that in some place. You also have some newer deployments that support RESTconf and all those other type of interfaces. But clearly, the important thing is once you build that library stays with you. The other problem to solve this would be to onboard all those different vendors' optical networks and keep track of all those things. That's very complicated. So if you can minimize the problem as we've done here, it just makes it a lot easier to deploy, right? So that's important. You have that library, it can be reused, it can be updated. And then you use, what we call a microservice builder or an object builder. And what that microservice library does is, it, again, gives you the ability to add different functionality to each one of the different domain controllers. So you can control different aspects of it. Some domain controllers may support, for example, latency, or as I said before, or they may support redundancy capabilities. And you'll add that as a microservice to that particular controller. And as other controllers add that capability, you can use that same microservice to add those across the board. And then finally, you have an infrastructure that supports or workflow and allows you to do the workflow for providing services. The initial thing could be providing a private Ethernet service, as I showed in the previous example, across the board, but you can have other workflows, obviously simple ones like delete service, modify service, extend a service, or even having workflows for tenants that you have in the network. And then finally, you have this across-the-board portal that gives you access from an administrative point of view as an operator to support the entire network, right? And also the ability to give a tenant portal and sell that portal as part of your service offering. So very, very important. So these are just, I didn't want to leave without saying this framework doesn't just support optical service orchestration, but it supports examples of other capabilities and automation use cases, right? I mean, everyone's heard about security. It's a big hot button, but security logging, we've had deployments in those areas. They're supported. Service chaining and the ability to do a service chain overlay on top of network connectivity infrastructure is something that's supported and deployed. Also, we've done a number of things which, for example, supporting IT use cases. A good example of that would be a use case where an IT organization for a business needs to especially for, let's say, a development business, needs to add contractors or new development or projects on a regular basis. And in that case, what we've done with the infrastructure is allowed the IT organization to quickly spin up the capabilities for those resources. Because I think what a lot of people forget is you can add people, and even that's tough. But once you add the people, you have to add the infrastructure quickly in order to take advantage of those people to make your projects go faster. And that capability we've added from an IT perspective. And there's also some other ITs from an enterprise infrastructure. And then, of course, I have the, my favorite, the optical service orchestration part. But, and then finally, the ability to set up SD-WAN or edge connectivity and overlays on that connectivity, and then add that, connect that with service chaining is also something that we've had. So the framework I showed earlier is flexible, right, and is very secure, highly available, which is a key requirement for many operators. I've seen a lot of the systems that are talked about today don't even think about high availability and the importance of it. I was listening to the Amazon talk earlier, and there was some discussion about, oh yeah, if it fails, that's okay. I agree, there's environments where that's important, but I don't know anyone here that is happy when their service fails or their connectivity fails, right? There's always something issue for that. So we make sure that our systems are highly deployable and highly available. And customers request that. So if you're going to a customer and there's a trade-off, high availability is important. So what I wanted to summarize is just to give you a sense of the value, again, of this optical service orchestrator concept, right? Basically, you have a single pane of glass to manage all these domains. It could be 6 or 7 of them or even more in a network, and it just simplifies the operations for a service provider. It delivers zero-touch service lifecycle management and capability, and enables you to provide your tenants or your customers to create their own services anytime they want. I mean, this is something I know folks in here say, hey, we've been doing this in the IP world, but in the telecom space and the optical space, there are challenges that have made that almost impossible in the past, and now we're making that possible. So I'm excited about that. And then finally, it delivers productivity gains, right? Because you can focus the folks that were working on the manual tasks and focus them on other areas, and also allows you to focus that, the capability of that team faster, or that product faster, and deliver the product faster. You can, in this case, when we deployed, it took the service provider, it used to take a month or 2 to set up a connectivity service and verify it, and now this is done in seconds, basically. As soon as the controllers talk back to you and say, hey, my service is up, the service is going. And then finally, it just expands the capability of your service offering and gives, from a service provider, gives you an edge from a deployment standpoint. So thank you very much. I hope this was different and something that was of interest to you.